Hello and welcome to this GCSE Chemistry mini-masterclass. In this session I'll be focusing on all of the essential knowledge on how to prepare a pure dry sample of salt crystals. This is a required or core practical for a number of different exam boards such as AQA and edXcel. As always, there'll be plenty of exam practice where I'll be modelling my approach to some exam questions myself, as well as giving you the opportunity to have a go at some at home. Let's get cracking. So if you've watched my previous video on acids, bases and neutralization reactions, you'll already have seen this. Quick reminder that a base is a chemical that reacts with an acid to form a salt and water. Bases have a pH greater than 7 and alkalis are just soluble bases. In a neutralization reaction, the product will have a pH of 7, which can be tested for using an indicator such as universal indicator, which would turn green, or a pH meter / probe, which would give you a value of 7. Some different acid and base reactions that you need to be aware of are shown in this table. Notice that we always produce a salt and we always get water as a minimum in our product. Now, when it comes to naming the salt, remember the first part of the name comes from the cation, the positively charged ion from the base, which is normally a metal, and the second part of the name comes from the anion, the negatively charged ion from the acid. Now, you'll notice in these three examples, the name of the cation portion remains unchanged. That's the easy bit. The name of the anion portion in the salt is dictated by the acid. Hydrochloric acid forms a chloride, sulfuric acid forms a sulfate, nitric acid forms a nitrate, and you need to remember those salt endings accordingly. A final acid and metal reaction, this is a fourth reaction that is not a neutralization reaction because you don't produce a salt and water, is this one shown here. Again, I covered that in my previous video. Now, a little example then of a word equation that we might have to complete in an exam that requires us to apply that knowledge is this one shown here. And I've been asked to complete the word equation for the reaction of calcium hydroxide with an acid, don't know what the acid is, to form calcium chloride. Now, I need to apply my knowledge of acids and salts to determine what acid is being used to produce the chloride, calcium chloride, as shown here. So it's got to be hydrochloric acid, and as it's a base and an acid that's reacting here, and I'm going to produce a salt and water. 1 mark for each. Have a little think yourselves at what acid and base would be needed to produce the salt lithium sulfate. Pause the video, have a little think, and I'll review in a moment. So we would require sulfuric acid because it's lithium sulfate that we're trying to produce, and possible bases are lithium oxide, lithium hydroxide, or lithium carbonate. Okay, they've all got lithium in to produce our salt, lithium sulfate, and obviously bases are normally oxides, hydroxides, or carbonates. Now, the required or core practical that's associated with producing a pure dry sample of salt crystals relates to various different pieces of equipment, or apparatus as they are sometimes referred to in exams. And this little diagram here is showing you the different pieces of equipment all labelled up. And what I'm going to do now is talk through the method of this, and then we'll move on to some exam questions. So to begin with, we require our acid. And if we are trying to produce a pure dry sample of, let's say, copper sulfate crystals, those blue crystals that hopefully you've produced in the lab yourselves, we would need sulfuric acid, and we would add that to a beaker. We'd warm it gently using a Bunsen burner. We would then add a little base, and my base has got to be a base containing copper, such as copper oxide, which is a black powder, and we'd add that base and we'd stir. We'd keep on adding the base until no more react. In other words, it will remain undissolved. I'd have solid bits of copper oxide in my beaker of solution. That's called adding it in excess. And the reason we do that is we want to make sure all of the acid has reacted. Okay, we don't want any acid left over in our product because it would affect the formation of our crystals. We've got the word equation associated with this reaction here. Now, what I've got to do is remove the excess base next, and I do that by filtering the mixture, because at this stage I've got copper sulfate solution, i.e. copper sulfate, water, and my excess copper oxide, so I need to get rid of this, so I filter it out. The next job is to heat the solution using the likes of a water bath or an electric heater to what's called the crystallization point, or we can just say to evaporate some of the water. So we're getting rid of this bit because that's what we want. Finally, we're going to leave the remaining solution to cool down and crystallize. And we could also add at the end that a little bit of drying of the crystals with the likes of filter paper can be done as the final step. So some exam questions then. I'm going to model these first few myself and talk through my thoughts on how to approach these exam questions. So the first one is asking me to complete the word equation for the production of potassium nitrate. So I know that's got to be a product. As shown in figure 1 from the reaction of my base, potassium oxide, with a named acid. I've got to come up with the acid myself. Well, first thing I'm going to do is put the known product, potassium nitrate, into the word equation. Next thing, what's the base? Well, the base has got to be potassium oxide. Again, I'm told that in the question. Because I'm producing a nitrate as my salt, my acid is going to need to be nitric acid. And then I'm applying my knowledge of bases and acids. I always produce a salt and water. I get 1 mark for my reactants, 1 mark for my products. Next one. What observation, in other words, what can I see, can be made to determine that the potassium oxide has been added to the acid in excess? Well, I have got a little diagram here to help me, and I can see the unreacted potassium oxide labelled there. I'd expect to see or observe solid potassium oxide remaining in that solution, so it's not dissolved. Describe how the excess potassium oxide could be removed. Okay, so I've got to get the large solid bits of potassium oxide out of that solution. Well, I'd filter it, that gets me a mark, and then I've got to give some equipment that I would use to use that for my second mark, so a funnel and filter paper. Next question, suggest the name of one other compound that could be added to the acid to produce potassium nitrate. So I've got to come up with a different base. Okay, it's going to have potassium in it because I'm making potassium nitrate as my salt. But I've got to think about what other bases I could add to that acid to make potassium nitrate. I could have potassium hydroxide or potassium carbonate as my possible answers for that one. And finally, I've been asked to describe a technique, in other words, a method of producing potassium nitrate crystals from the solution that I've formed. So I've taken out the excess base, and now what I'm left with is potassium nitrate dissolved in water. I want to get rid of the water. How am I going to do it? I heat the solution. That gets me a mark. To evaporate the water, then leave it to cool. Okay, that's required for the second mark there. Right then, some for you to have a go at. Pause the video, give yourself no more than 6 minutes on these questions, which is a mark a minute plus 1. And I'll review in a moment. First one then. Solid zinc oxide remains. Okay, that's how I would know that it's been added in excess. Okay, the bit in bold or the bits in bold are the essential parts for the mark in that response. Why is excess zinc oxide used rather than excess hydrochloric acid? We can either say that the zinc oxide can be filtered out or removed by filtration, or that hydrochloric acid cannot be filtered out. Yeah, the molecules of hydrochloric acid are far too small to be removed using filter paper. They'd pass through. Next, naming another compound that could be added to the acid. You could have zinc hydroxide or zinc carbonate as your alternative bases. And for the final one, how could we obtain crystals from the zinc chloride solution? We would heat the solution to evaporate water. Again, bit in bold there is essential. Or we could say heat until the crystallization point. Second mark, we would then leave the remaining solution to cool down. 2 marks for that one. An alternative question then. This one, 3 marks for describing how a sample of pure dry nickel sulfate crystals could be obtained from a mixture of nickel sulfate solution and excess solid nickel carbonate. Okay, so they've already added the nickel carbonate in excess to the sulfuric acid. Now, this is a we do, so I've given you an example response from a student, including the mark scheme. What I'd like you to do now is pause the video and have a think about how many marks that would be worth. Okay, let's review that then. So our student would get 1 mark for mentioning filtering, and they'd get 1 mark for mentioning cooling down. Now, some of you might have thought they'd get a mark for referencing the use of a Bunsen burner, and that's a common answer I see from students when I'm doing my examining. You must mention that the Bunsen burner is providing heat, okay? Otherwise, it could be a turned off Bunsen burner for all I know. So they've not got the mark there for the heating of the solution, okay? So it was just 2 marks that they've picked up from our mark scheme here. A final one for you to have a go at home, okay? You've just seen a very similar question on the previous slide. Have a go at this one, and I'll review in a moment. Okay, so the only difference here was your base and your acid. The rest of the steps were the same as previous. So we get a mark for mentioning filtering the solution or using filtration to remove, obviously, our excess iron oxide. That has to come first to achieve full marks in this response, and then any 2 from the list shown here. Okay, either heating the solution to evaporate water, mentioning of crystallization, leaving to cool, or you could have mentioned at the end drying the crystals with filter paper. And that's a wrap. If you found that video useful, please hit that like button, and for more science mini masterclasses you can subscribe to my channel. See you in the next one.